In this video, we'll interface the cart component as well as our app component with Redux using hooks instead of the connect higher order function. We'll use the useSelector and useDispatch hooks, and we'll also implement optimizations using the shallow equal function from React Redux and the memo higher order function from React. Let's begin. When working with the catalog component, we used the connect higher order component. Redux added support for the hooks API in version 7.1.0. We'll be working with two major hooks from the React Redux package. The useSelector hook allows you to extract data from the state, somewhat like the map state to props function when using connect. On the other hand, the useDispatch hook can be used to get access to the dispatch function so that actions can be dispatched from the component. Let's put them to use in our project. Once again, continue working with the outcome of the previous video, or you may download the project from the link given on the screen. The cart component renders two components, namely cart item and cart totals. Based on the contents of the items array in the cart, multiple instances of the cart item component are rendered. The cart totals component just displays the total number of products and the total cost of the cart. So let's access the cart state tree from Redux. We are going to use Redux hooks, which means we don't need to use connect to wrap the function first. I'll first import the useSelector hook. This hook allows you to fetch data from the state. So let's extract total cost, total products, and the items array. Just like the map state to props, the useSelector hook has access to the entire state tree. Hence, we need a function to filter and get a portion of the state as needed. Here, we are only accessing the state.cart object. You can now use this data normally as you would in a React component. Let's try adding some products to the cart and see what happens. We don't see anything. Can you guess why? Well, we still haven't equipped our add to cart button to dispatch the add to cart action. So let's take a moment and head back to the catalog component for a bit. I'll import the add to cart action creator from the cart actions file. We'll then add a prop named onAddToCart to the map dispatch to props function, which accepts a product object and dispatches the add to cart action with it. We'll then add the prop to the component, and I'll invoke it when the onClickAdd button prop is invoked from the product component. Now let's try and add a product from the catalog, and you can see the cart come to life. Our cart reducers are working as expected, and we can see the totals at the bottom. I'll now try and hit the add to cart button multiple times on an item that already exists in the cart, and you can see that only its quantity is incremented and all computation also updates as desired. We now want to dispatch the set quantity action when the quantity value is updated in the input field here. Likewise, we want to dispatch the remove item action when the remove button is pressed. I'll first get the useDispatch hook from the React Redux library, and we'll get access to the dispatch function first. We'll then import the set quantity and remove item action creators from the cart actions file. The cart item component offers a prop named onQuantityChange, which is triggered when the user changes the value in the input field. When this happens, we get the value of the input field here. So if the value set by the user is 0, we want to remove the item from the cart. So we'll dispatch the remove item action with the product code. On the other hand, if the value is not 0, then we'll dispatch the set quantity action, passing in the product code and the quantity value. Oh, this needs to be item.code and not code. Okay. When the remove button is clicked, the on item remove prop is invoked, and here we can dispatch the remove item action with the item code. That's it. Let's test this out now. And you can see it works beautifully. Now let's talk about optimizations and how we can improve what we have implemented here. Whenever a function component renders, whether due to a change in props or the parent component rendering, the useSelector is called again. At this time, if the value to be returned has not changed, the useSelector typically returns a cached result. Internally, it uses a strict equality check to get the result. When fetching objects with the useSelector, especially when an action is dispatched, the strict equality check doesn't achieve a desirable comparison, and this forces a re-render even if the values in the object are the same. On the other hand, when working with the connect higher order function, shallow equality checks are implemented since the map state to props function returns one single object with multiple state properties. This means that re-renders are only achieved when one or more of the individual properties change and not otherwise. Connect also prevents a component from re-rendering if a parent component has re-rendered. We don't get such optimization benefits with hooks and when fetching data from the state. One solution to the problem is to extract individual properties using individual useSelector instances, as you can see here. Another solution is to use the shallow equal function, which can be passed as the second argument to useSelector. This implements the shallow equality check and solves the problem for us. So let's implement these optimizations. First up, since we are returning an object from our useSelector, I'll import the shallow equal function from React Redux, and we'll set this as the second argument to the useSelector so that a re-render is only forced if one or more of the individual properties change. But one problem is still not solved here. If any of the parent component re-renders, then the cart component will be re-rendered again. This is standard React, and when that happens, the useSelector is called again. The connect higher order function does save us from this issue. So to implement this optimization here, I'll import the memo function from the React library. Memo is a higher order function that implements memoization, a technique that caches your component and prevents a re-render if props are not changed. In this case, it will also prevent our component from re-rendering as a side effect of a re-rendering parent, which solves the problem for us. To use the memo function, just wrap your component in an invocation of memo. This way, we have implemented optimizations that you tend to lose when working with the useSelector hook. Now, one more thing left to do. Let's go back to the app component, and we have this items prop in the cart button component. Setting this to anything other than 0 renders a badge with the number. This is used to display the number of items in the cart. So let's fetch the total products value from the state and plug it here. I'll get the useSelector hook, and this time we'll extract the property directly. This is efficient because you're doing a strict equality check with a single value and not an object. And since this is the topmost component, I don't need to implement memoization here. And we're done. You can see the badge updating here. With this done, there are only two things to implement in our app. First up, what if we want Redux to transact with an API? Real-world apps will interact with APIs when actions are dispatched. We are talking about the usual suspects such as fetching data, storing and updating data. How can we achieve this with Redux? And what if we want to persist our cart so that if the browser window is accidentally closed, we don't lose its contents? Let's answer these questions in the next and final video of this module.